Okay, so my question. 42. Triangle ABC has vertices with coordinates A, -1, -1, B, 4, 0, and C, 0, 4. Prove that triangle ABC is an isosceles triangle but not an equilateral triangle. Okay, so I'm not going to be using this. Okay. So, to do an isosceles triangle it has two sides of equal length, and an equilateral triangle is all three sides are equal. To do this, we need to use the distance formula to prove that triangle ABC is an isosceles triangle but not an equilateral triangle. Okay. So, AB, so this is the setup that I have. Okay, so now to solve it. So since it's both negatives to each other, that turns into a plus. So 4 plus 1 squared plus 0 plus 1 squared. This is 5 squared plus 1 squared. 5 times 5 is 25 plus 1 times 1, which is 1. This gives you 26. So radical 26. AB equals radical 26. BC, this is the formula that I have set up. Okay. So 0 minus 4 is -4 squared plus 4 minus 0, which is just 4 squared. So a negative times a negative gives you a positive. So -4 times -4 is 16 plus 4 times 4, which is 16, which gives you, this gives you 32. So this is radical 32. Okay. And finally, AC. This is also the formula that I have set up. Okay, so since they're both negatives, it's 0 plus 1 squared plus 4 plus 1 squared. Okay. So that's 1 squared plus 5 squared. 1 times 1 is 1, and 5 times 5 is 25. This gives you 26 squared as well. 26 squared. So as you see, segment AB, which equals radical 26, and segment AC, which also equals radical 26, gives you an isosceles triangle. So this is an isosceles triangle, but not a equilateral triangle, because, I'm gonna write it down. ABC is an isosceles triangle, but not an equilateral triangle, because it only has two sides of equal length, which are segment AB and segment AC, which both are radical 26. But this is not